going to talk about green accounting. I'm going to talk about GDP. I'm going to talk about productivity growth. I'm going to talk about the environmental product. And then probably at one point somewhere here we're going to have a break, perhaps a little bit earlier. And then I'm going to talk about alternative estimators, genuine savings, ecological footprint. We almost reached the end, as Emily said. Almost, we're not quite there. But it is the final week and the final lecture. So let's start with GDP. So gross domestic product is the conventional measure of economic performance, tracking the economy over time, and if you look at it per capita, comparing economies over space. It was originally proposed by Simon Kuznets, and the first estimates for the United States were published in 1934. This is the standard story that Kuznets did it. But if you look closely, he actually had help by Lillian Epstein, Elizabeth Jenks, and Edna Ehrenberg. Edna sort of came onto the project late and really seems to have been an assistant type of person. Lillian and Elizabeth were long-term collaborators on this particular project, but it's typically Simon because he's the senior male who gets all the credit, right? So that is where it comes from. Already 2 years before its publication of a report to Congress, Kuznets said that the welfare of a nation can scarcely be inferred from a measurement of national income. It took them a couple of years to actually come up with a definition and put all the numbers in place. And while they were working on it, Kuznets already realized that this is not a measure of welfare. This is simply a measure of economic output, a measure of total economic activity. There are 3 alternative ways to measure GDP, according to whoever put this table together, I forget. Thought that they were identical, but they were only identical in principle, not in practice. You can measure GDP by total demand. That is, how much is consumed, how much is invested, how much does the government spend, and then correct that for how much you sell abroad minus how much you buy from abroad. And if you add up all these measures and then also correct for inventories, you have a measure of GDP. Alternatively, you could look at the sum total of production measured by value added in agriculture, manufacturing, services, and then you have to add VAT. If you do that, you have a perfect measurement. You also get to the hopefully same number of your GDP. So this is total production, this is total consumption. You can also look at total income. That is, how much is paid towards labor, how much is paid towards capital. So this is profits, dividends, and so on and so forth. And again, the state is also an actor, so you also need to look at total state revenue. If you add up all these numbers, correct for amortization, then you also get the GDP. Aiden, you just stuck up your hand. Right? So this is just a recap. This is what is GDP, and you should recall this from principles. Standard measure, as I said, proposed in 1934 by Kuznets and colleagues, and essentially adopted worldwide after World War II. But GDP has long been criticized. Perhaps the most famous criticism is from RFK Sr., not Jr., and there's a big difference in quality between father and son. RFK Sr. said, too much and for too long we seem to have suspended and we have surrendered personal excellence and community values in the mere accumulation of material things. Our gross national product now is over 800 billion a year, but that gross national product counts air pollution and cigarette advertising and ambulances, to clear our highways of carnage. It counts special locks for our doors and the jails for people who break them. It counts the destruction of the redwoods and the loss of our natural wonder in chaotic sprawl. It counts napalm, this was during the Vietnam War, and counts nuclear warheads and armored cars for the police to fight the riots in our cities. Again, this was during the Vietnam War. It counts Whitman's rifle and Speck's knife in the television programs which glorify violence in order to sell toys to our children. Toys rather than computer games. Yet the gross national product does not allow for the health of our children, the quality of our education, or the joy of their play. It does not include the beauty of our poetry or the strength of our marriages, the intelligence of our public debate, again it's a long time ago, or the integrity of our public officials. It's a long, long time ago. It measures neither our wit nor our courage, neither our wisdom nor our learning, neither our compassion nor our devotion to our country. It measures everything, in short, except that which makes life worthwhile. That was RFK, right? And this is a fair criticism of GDP. It measures economic activity. It does not measure happiness, right? Or utility. And it's important to make that distinction. So there's all sorts of things wrong with GDP as a measure of anything but economic activity. The first is that it includes investment but not depreciation, right? This is Bastiat's broken window fallacy. Here you see Bastiat. Essentially, if you break a window, that does not reduce GDP. But if you then repair the window or have it repaired, that does increase GDP because you have to pay for the new window, you have to pay for the person who installs it, right? The solution to this particular problem is very simple and actually very old. And that is that you should be looking at net domestic product rather than at gross domestic product. That is, you should subtract depreciation, that is breaking of a window, from your GDP. Problem with NDP is that data are much harder to get because depreciation is hard to measure. Another problem with GDP is that it's limited to market transactions. So you cleaning your room does not count towards GDP, but you hiring somebody to clean your room, this is unlikely, I would think, but suppose you would, does add to GDP, right? Similarly, if you have a piece of land and you grow food and you eat that food that you grew yourself, there's no market transaction there. So that does not count towards GDP. Whereas if you sell your produce and then buy what you eat from somebody else, that does count towards GDP, right? Talked about defensive expenditure before, does not count towards GDP. Crime does not count towards GDP. The map that you're looking at in red, marijuana pot is illegal. In blue, it is legal, and then the yellow and pink are somewhere in between. If you move, some countries have done, Germany, Canada, South Africa, if you move to legalize pot, then your GDP goes up because a part of the economy that used to be illegal and therefore not measured was not there. And then you change the law and all of a sudden on the 1st of January your GDP jumps by whatever the size of the marijuana market, right? Which is a bit of a nightmare if you're an official statistician, right? Because nothing has really changed, just that your measurement of things have changed, right? And as RFK Senior said, stuff that is going on in the environment, environmental damage, is also not included in GDP. And then GDP is sum total of everything that's going on in the economy. So by definition, it does not look at the distribution of income, and it also does not include sort of these immaterial things that are not quite public goods but more general rights, such as freedom of assembly, freedom of speech, freedom of movement, and so on and so forth. Those things are not included in GDP either. So GDP is fine if you want to look at economic activity. For all other things, it's actually quite suspect. And that can create problems. The first problem that I'm going to talk about is if we try to measure productivity growth and we don't measure GDP as we would like it to be measured. So I'm going to recap a little bit from your macro, and then I'm going to extend it to the environment. So assume that we have an economy where we have two factors of production, production Y, and the two factors of production are labor L and environment E, right? Of course, in macro you did it with L and K, but that doesn't matter, right? So we're going to change all variables by a little bit, right? We have a little bit more labor, we have a little bit more environment, and we have a little bit more productivity, right? A is sort of like the solar residual that sweeps up total factor productivity. So if we change the three inputs, then output is also going to change a little bit by delta Y. Then we're going to take the production function f, and we're going to use the first order Taylor approximation. First order Taylor approximation is always that if you have a function of two inputs, then that thing is approximately equal to its base position, that is f of L and E, rather than L plus delta L and E plus delta E. So this is the base level, plus the first partial derivative of the function to L times the change in L, plus the first partial derivative of the production function to E times the change in E, right? This is approximately true. And if delta L and delta E are 0, it is true, right? Because then we have just that FLE is FLE, right? And for small delta L and small delta E, this is approximately true. Now, what we can do is replace this expression here with this approximation. Then what we have is A times FLE, which is just equal to Y, right, by definition. And we had a Y on the other side of the equation as well, so that cancels, right? So now we have an expression for the change in output is the change in productivity times our initial output level. No, times our initial production, sorry. Plus the change in labor times the first partial derivative, plus the change in environment times its first partial derivative, right? So that equation is copied here. Then we're going to divide everything by Y, which is easy enough, right? For these two. And for this expression here, what you need to realize is that Y is A times the production function. So that cancels here, and we have delta A over A. Now, we can stop here, but this equation is not that easy to interpret. We're going to assume that the economy is in an equilibrium and that it's an undistorted economy. And in that case, the price of labor, how much wage you want to pay to your workers, is equal to their marginal productivity, the FDL, times how much you get for the product that you sell, right? So this is marginal productivity in physical units. This is the marginal profitability of hiring an additional worker, right? And then this is the wage that you pay. So this is simply an arbitrage condition, right? If this is true, then this is true as well, that your marginal productivity is the price of the input over the price of the output, right? So that means that in this expression here, we can get rid of this marginal product, this marginal productivity, by replacing it with the price ratio, right? Relative price of labor to output. Then we have this thing here, y times py, which again, if the economy is in equilibrium, your total output, actually the economy does not need to be in equilibrium, this is your GDP, right? It's the total output times the price of the output. So that is total production. This is your total factor payment. So this is one of the alternative measures of GDP, right? So this is your total input in labor, or the value of it, and this is your total input in environment, or the value of it, right? You add up these two, and by definition, these are two alternative measures of GDP, right? So now we're here, and then we can rename this as the labor share in the economy, right? So we have an expression for this thing. We can replace that with this. Well, we can substitute that back in. We can do the same for E. And then what we have is that total factor productivity, the relative change in total factor productivity, is the relative change in total output minus the relative change in the labor input times the labor share of input minus the relative change in environment times the environment share, right? So we can do that. Then we can divide both sides of the equation by the change over time and replace the A dt by A dot, right? And the same for y and L. And we have that the proportional growth rate of productivity is the growth rate of output minus the growth rate of inputs times the cost shares of those inputs, right? This you recall from your macro, right? I don't know who teaches you macro, but whoever it was should have given you this. And this is the solo residual, right? We measured productivity growth by looking at how much our output grew minus how much our inputs grew, right? Now, the reason that I replaced capital with environment is because this is environmental economics, right? But it is just still solo residual if you replace the E's all with K's, right? But the problem with environmental inputs is that they're hard to measure, right? Now suppose that we can't measure the environment, right? So really what the national statisticians do is say, well, our output is not really total factor productivity, but this is sort of a distorted measure of total factor productivity, A star, and then we have a production function that only depends on labor, right? So we are now in the situation that we have an imperfect measure of the things that drive our economy. So this is wrong, right? The solo residual becomes biased, and its growth rate is biased too. That can be seen as follows, right? If we assume that the environment grows at the same rate as the stock of labor, then what we have is that total factor productivity is simply output growth minus labor growth, right? So you have two inputs, they grow at the same rate, so actually the shares do not matter anymore because those assets add up to one anyway, right? So this is implicitly what you assume if you say, well, I can't measure what is going on in the environment. But let's now assume that the two growth rates are not the same, but the environment grows less fast than labor, right? We subtract a minus B. Of course, if you assume that the environment grows faster, the B becomes negative. If you assume that the environment is collapsing, then B becomes very large and may actually overwhelm the growth in the labor force, right? B is an arbitrary number, but just for illustration, I subtract it here. This is true. Then the equation that I derived before becomes this, right? SL, SE, LE, and then substitute E dot E with this thing here. So we minus B here, but because we subtracted it, two negatives become a positive, right? So we add this thing essentially. So this is what we measure. This is what is going on. The implication is that if environmental productivity grows less fast than labor productivity, we have a positive B, then total productivity seems to grow faster than it really does. And the intuition here is that you have a drag on your production because one of your input factors is not doing very well, but that input factor is not measured, and anything that is not measured ends up in your solo residual because it is residual, right? The whole trick about growth accounting is that we have this residual measure named after Robert Solow that's essentially soaks up everything that we cannot measure. And everything we cannot measure we call total factor productivity, right? And some of it is genuine productivity and some of it is stuff we do not measure, right? Now if we have a drag on production that we cannot see, then it is as if our productivity grows faster because essentially we're making up for that drag on production. So this is the theory, right? Robert Repetto, who you see here when he was, this is older work, as you can see, it stops in 1992, and Robert has aged since, apply this to two parts of the US economy. Electricity at the top, agriculture at the bottom, and the dotted line is your standard measure if we use the official national accounts of the United States from 1970 to 1990. And the solid line is if you include the environment, right? And what we have here is actually the reverse of what I said before, because we can see the total factor productivity, real total factor productivity actually grew faster than actual or measured total factor productivity. So the actual is greater than the measured one. And that is because over this period, the power sector really cleaned up its act in terms, and we talked about removing sulfur before. We also talked about the switch from coal to gas for reasons unrelated to the environment, everything to do with prices, which took away a lot of sulfur, which took away a lot of particles, which took away a lot of CO2. I don't think that Robert actually looked at CO2, I'm not sure. And actually, the environment greatly, or the environmental pressure put, or the pressure put on the environment by the electricity sector actually fell fairly rapidly through this period, and that is why the solid line is so much higher, right? And the same is true in agriculture, but to a lesser extent, right? There you also see particularly pesticides from 77 to 92 where the use of pesticides was reduced substantially in this period, right? But the takeaway message here is that if you mismeasure GDP by excluding an important part of GDP, in this case the environment, it's not just that you get your measure of GDP wrong, but you also get your measure of productivity growth wrong, right? And that was a question that we had on the exam last year. Things have been moving very fast in the environment in the UK, and productivity in the UK has been very stagnant, right? And could it be that the environmental improvements have something to do with the lackluster growth of total factor productivity in the United Kingdom? And we can talk about that tomorrow or Wednesday. So that is the first implication of just not getting your GDP measure right, or one of the major implications. The next question is, how do you actually correct for this, right? It's obvious that a measure of total economic output that ignores things that are going on in the environment is simply wrong. And I'm going to answer that question in 4 stages. First, I'm going to do some more theory. You'll love it. And then I'm going to look at what is going on in the UK, what is going on in the World Bank, and then what is going on in the wider world out there. So how do we put this into GDP, right? Well, actually, what people thought of first was fairly basic, right? So GDP is consumption plus investment. And then we said, well, actually you should look at NDP. You should do consumption plus investment minus depreciation, right? The environmental net domestic product is essentially the same, right? We should subtract sort of the net degradation of natural assets, and we should add all the positives, all the immaterial consumption that we get out of the environment, right? Conceptually, this seems straightforward. There is actually a proper derivation of this, rather than say, oh, this seems like a logical way of doing it. And that goes back to a man we've met before, when he was much younger, Marty Weitzman, who you see there being as cocky as he was, right? It's hard to say how old he is. I'd say he's around 30 at this time. And I believe in, there we are, my computer stopped. I believe in 1974, but around that time, don't cite me on that, he did an important piece of theory. So let's assume that we want to maximize net present utility by choosing a stream of consumption C. And now I'm doing something naughty, right? That usually we write the net present value as the sum of utilities at every point in time, multiplied with a discount factor 1 over 1 plus rho to the power t. But I do not do that here, right? I replace the sum with an integral. And then, of course, I have dt here. It's an integral over time. And I replace the discount factor with e to the power minus rho t. So I'm being naughty here, right? This is not what you're used to. Now, if you pay close attention at calculus, then you would know that the function 1 over 1 plus rho to the power t, if you shrink the time steps of t, then 1 over 1 plus rho to the power t converges to e to the power minus rho t. So typically we think of discount rates as annual, right? And then the discount factor is 1 over 1 plus rho for the first year, 1 over 1 plus rho squared for the second year, 1 over 1 plus rho to the power 3 for the third year. But why would you do it in years, right? You could also do it in days, essentially. Right, so for the first day it's 1 over 1 plus not rho, but another number, 1, 2, 3, and so on and so forth. And that is actually how your bank calculates interest rates, right? They give you an effective annual rate, but they don't calculate your interest on your loans on an annual basis. They actually do it on a daily basis. But there's actually no reason why you would do it on a daily basis. You could do it per hour. That's how banks do it amongst each other. Or you could do it by minute or by second. Or you can do it in infinitesimally small time steps. And if you do it in infinitesimally small time steps, then this function emerges, right? It's the same thing. So I simply replaced discrete time with continuous time. And then we, of course, also have a budget constraint. And if you work on the budget constraints, then you know that your change in capital stock, so this is investment minus depreciation. Change in capital stock, that is k dot, right? Dot always means a change over time, is your investment, I, minus your depreciation, right? We assume that we depreciate a fixed fraction delta from your capital stock. So this is one budget constraint, one constraint that you need to meet. And then the other constraint is that your total production is a production function. We only have capital as a factor of production minus your consumption, right? Your investment is production minus consumption, right? It's a closed economy. So this is the thing that we want to maximize. Now, you look at me like I've never seen a problem like this before. This, I think, is true for at least 6 in the room. Not sure about Jana. But the economists definitely haven't seen a problem like this in their lives, right? You're used to constraint optimizations and then solving them using the Lagrange method. That is something you have seen. This is a problem in continuous time, and you can use Lagrange, but it becomes horrendously complicated. Instead, we're going to use Hamilton's method, right? The reason that we do this is that Lagrange problems work fine in discrete steps if you have a finite time horizon. Actually, it becomes pretty hairy if you have a finite time horizon. If you have a static problem, then Lagrange works fine. For dynamic problems, Lagrange type of solutions get you into all sorts of very awkward mathematics, right? And the Hamiltonian method is actually much simpler, right? And I don't know why we don't teach you this. Because Hamilton is actually fairly straightforward. So, what do we do? What do you do if you have a constraint optimization problem? You form the Lagrangian, right? No. If you have a problem in continuous time, you don't form the Lagrangian, you form the Hamiltonian, right? Because it was invented by another guy, right? A Scottish guy rather than a French guy. The Hamiltonian, lo and behold, is not a calligraphic L, but it's calligraphic H, right? No surprises there. The Hamiltonian is actually surprisingly simple. What you do, this is the current value Hamiltonian. There's two Hamiltonians, but when I say Hamiltonian, I mean current value Hamiltonian. What you do is you take your objective function and you throw away all the funny bits, right? So you throw away the integral, you throw away the discount factor, and if you throw away the integral, you also want to get rid of your dt, right? So you just take the current value of your objective function, u, c, t. So that is fairly simple. The second component of your Hamiltonian is also fairly simple. It's actually simpler than the Lagrangian. Instead of taking your constraint and writing that inequality as an equality and then multiply it with the shadow price, you just take the left-hand side of your constraint. So that's k dot, right? Not k dot minus this or k dot plus this. You just take the left-hand side of your constraint, simpler, and you multiply it with a lambda. And because we're now a Hamiltonian, we don't say that this is a shadow price. We say this is a co-state variable, right? But it's a shadow price, essentially, right? So this is actually a simpler thing than the Lagrangian. And then we have two first-order conditions. The first third-order condition is entirely familiar to you. You take the first partial derivative of not the Lagrangian but the Hamiltonian to the thing that you decide on, that's your c, and you set that equal to 0. So the h, the c, is marginal utility. This thing is actually not difficult either, right? Because we know that k dot depends linearly on c, nothing else. So your plus lambda becomes a minus lambda. And this thing must equal 0. So that is your first order condition for static efficiency. But we have a dynamic problem, so we also have a first order condition for dynamic efficiency. And that looks weird, right? It essentially says that the change in your co-state variable, or your shadow price, minus your discount rate times the shadow price is equal to the first partial derivative of the Hamiltonian to the relevant stock variable, in this case k. Now this is a differential equation, and differential equations are difficult, right? The good thing about Weizmann's derivation is that it's too much for Alex. The good thing about the first order condition for dynamic efficiency is that we don't need it in this particular application. In other applications you do, but in this application we do not. So we have the Hamiltonian here. Same thing here. What we know is that your shadow price is equal to your marginal utility of consumption. So we can replace the lambda with u sub c. Right? Again, a first order Taylor approximation. So utility is approximately equal to consumption times the first partial derivative of utility to consumption. the utility function. We have this thing here, so if you see there and there, so we can bring that to the other side of the equation. And what we have is this expression here. Now this thing you know, right? This is consumption plus the change in your capital stock. This is net domestic product, right? This is consumption plus investment minus depreciation. This is your NDP. And what Weitzman showed is that NDP is equal to the monetized, linearized Hamiltonian. And once he realized this, he wrote it up in a paper and called that paper the welfare significance of the net national product, right? Because essentially what Weitzman did here is say, well, we have these measures of net domestic product floating around in the literature, but nobody actually has derived where that comes from. When Weitzman actually says, well, this actually follows from an optimization problem, right? And this is an appropriate measure for for welfare in a dynamic setting. Now, what happens if we add nature and protection? And now we go to a much older Weitzman, right? Still cocky, but more. Still had a lot of hair, but fairly grey. So, we now care about the state of nature, right? We don't just care about material consumption C, but we also care about the state of nature N. We also spend money on environmental protection, P. And if we spend money on environmental protection, then we can't consume that money and we can't invest that money, right? So our budget constraint has changed. If we invest money on environmental protection, then nature gets better, right? So we have an N we added here. This is how much we spend on the environment. And this is what is going on in the environment. Solution hasn't changed, or the solution method hasn't changed. We want to maximize this thing. We now have two budget constraints. So we form the Hamiltonian by taking the current value of our objective function. So do away with the integral, do away with the discount factor, and simply stick this thing in here. Then we take the left-hand side of the constraint, multiply it with a co-state variable lambda. We take the second budget, or this is an equation of motion, it's not a budget constraint. We take the second equation of motion, take only the left-hand side and multiply it with another co-state variable. And we call that mu, because mu comes after lambda in the Greek alphabet, right? We have the first order condition for static efficiency. We added this term P here, but that doesn't do anything, right? So we still have marginal utility lambda, because N does not depend on C. We simply have lambda, and we had that before. We had this one before. And we now have a second set of first order conditions, because now we're making decisions about two things, right? We're making a decision about how much to consume, and we're making a decision in how much to invest in environmental protection. So we also have the HDP. We have P here, we have P here. So we have a lambda with a minus p, and we have a mu with a plus p. So our first order condition for static efficiency is that lambda equals mu. That's very convenient. And we then also have a second first order condition for dynamic efficiency. And again, we're going to ignore these two terms, right? We're not going to do anything with them. We're just going to focus on the static ones. So, what do we have? Here we have our Hamiltonian. We apply the same trick, right? So we have lambda k dot here, but we know that lambda is equal to marginal utility, so that happens here. We have mu n dot here. We know that mu equals lambda, and we know that lambda equals marginal utility, so that happens here. Then we're going to apply the same trick. So we take the first partial derivative of this thing, du dc, u sub c, we multiply that with c, right? So we linearize the material part of consumption. This expression we had before. This expression we simply put at the very end because it is uc as well. And then we linearize the utility function by saying we're taking total stock of nature and multiply that by the first partial derivative of utility to nature. So here we have the total stock of nature. Here we have the first partial derivative of un, du dn, u sub n, right? And then we multiply this thing by marginal utility over marginal utility, right? Which is just 1. So here we have marginal utility, here we have marginal utility, here we have marginal utility, and here we have marginal utility, so we can bring that to the other side of the equation. And this thing we had before, right? Monetized Hamiltonian is approximately equal to total consumption plus net investment plus the net change in the stock of nature. So the things that get better in nature minus the things that go worse in nature, right? And then this is how much enjoyment we enjoy. No, sorry. This is the total stock of nature, right? This is how much utility we derive from nature. And then this division here essentially puts this into monetary terms, right? U sub n over u sub c, this is the relative price in utils of nature. So this is essentially the monetized value of us enjoying blue skies, clean waters, pristine air, right? So the environmental domestic product is material consumption plus our enjoyment of nature and a clean environment, monetized, right? Plus the change in the physical capital stock plus the change in the natural capital stock. Right? That is what I just said. Now, I've done this with a fairly simple production structure with a fairly simple utility function, right? Of course, there are more things that matter to you than material consumption and the state of nature. And I could repeat this with 17 different attributes and 17 different equations of motion. That will not add any insight, right? That will just make the derivation not fit on a single slide anymore. But it will not yield any additional insight, right? So what older Weizmann did was essentially put a welfare foundation under the environmental domestic product. We've done the theory. So what happens in practice? The first two to actually propose something like an environmental product were Bill Nordhaus and Jim Tobin in 1972, and they called this the measure of economic welfare, which essentially is net domestic product, and then they subtracted economic bads like repairs, pollution control. They included what they called regrettable necessities, which we would probably call defensive expenditure, so police and defense. Of course, the world would be a better place if there were no crime and therefore no police, right? So police actually does not add to your welfare. It just makes sure that your stuff doesn't get stolen and you don't get murdered and that sort of stuff, right? So police actually does not add to your welfare. It just prevents worse things from happening. So it should be subtracted. And then they also added in sort of the things that are outside the market altogether or outside the legal parts of the market. They call this primitive and experimental, and essentially did not have any sort of theoretical basis like Weizmann's work had. It was just an ad hoc thing, essentially. But this particular work has sort of been used over and over and over again, mostly just with small twists, and renamed as the Index of Sustainable Welfare, the Genuine Progress Indicator, Sustainable Net Benefit Index, the measure of domestic progress. Essentially, it's all the same thing. An important thing here to realize is, of course, that some of the things that we count as goods, not really what matters is the total stock, but the annual service that we derive from that stock, right? So it's important to convert stocks to the annuities of the services. They also try to include human capital. And some people have tried to put this in progress. This is the genuine progress have tried to put this in practice. This is the genuine progress indicator for the United States from 1950 to 2004. Here we're looking at GDP per capita, and it has improved, but sort of seems to have stagnated. Is this the US? This is if you include the other things, and actually because of the cleanup in the environment, particularly also things becoming safer, people living longer, people being better educated, progress actually has been much more substantial than what you would see with a conventional measure. There's all sorts of issues here. How do you put values on things? We've talked about it for 3 weeks. Sort of saying that some expenditure is defensive is actually difficult, right? To what extent is the police necessary? To what extent do they do good? They also do community work and so on and so forth. And because of that slightly arbitrary nature of where do you draw the line between something that's productive and something that is defensive, you can actually manipulate the results. Also, if you start measuring inequality, I don't know whether you guys have looked at inequality. I think that's actually on for next term with Rashad, is that there are a great many indicators of the measurement of economic and other inequality, right? And therefore, there's a lot of degrees of freedom. The important thing to realize here is that these are still measures of weak sustainability, right? Because the only thing that matters is the total aggregate, and we're just adding up stocks of material capital and stocks of human capital with stocks of natural capital, and we assume that the only thing that matters is the sum total of these things rather than the individual components, right? So that is going on. What is also going on is that a lot of the national statistics offices, the official statisticians, have gotten involved, right? And actually a very good example of this is the United Kingdom's Office of National Statistics. They have taken this up with quite some zeal. And you can look at it on the website. I simply will not have time to take you through everything. They have a lot of stuff on emissions to air, with a heavy emphasis on energy and carbon dioxide. This is partly because there's lots of data on that, right? So it's easy to measure. It's of course also because climate change in particular, as well as energy, is a political priority, and therefore the ONS looks at this political priority. They're not supposed to do that, and they're supposed to be a bit more neutral than this, but really that is where their focus is. Emissions to air then follows, right? Because if you're focusing on energy, then you start measuring emissions to air. Bless you. But they actually don't know very little about emissions to water and emissions to soil, which I think is a bit unfortunate. They focus on CO2, other greenhouse gases, particulates, heavy metals. I'll show you an example of that. They also account what is going on sort of like closer to the economy. They're looking at the expenditure on environmental protection throughout the UK economy. They're looking at tax revenue, and then they also have the material flow accounts, which I'll talk about later. And some parts of it have valuation, but most parts do not. So let's look at the national accounts for vanadium. I think you need to say. Vanadium is something that you don't think you know, right? Because it's one of those weird metals that is out there. It's actually one of the rare earths, so it's becoming more and more important. It's sort of in your mobile phone and in the solar panel if you have one. Vanadium is also very toxic. It does two things to this mushroom. One, it gives it its red color. And also makes that if you eat this thing that you will be dead very, very soon after, right? So vanadium is highly, highly toxic. It's actually what makes this particular mushroom toxic. But what is in the environmental accounts for vanadium, and they do it for all metals, right? But I won't take you through all the tables. From 1990 to 2022, right? Somewhere here, but I won't take you there. And then they have two aggregations. This is sort of the crude aggregation. So it will tell you that in 1990, 32,000 tons of vanadium was used in agriculture, and 37, I can actually read it better here, 37 in mining, and 347 in manufacturing, right? And then for all economic activities. And that immediately identifies that if you're worried about this stuff, it comes out of manufacturing, it comes out of power, and it comes out of the, now I need to look closely, it's again easier to see here, it comes out of transport and storage, right? That is where, if you want to focus on solving this problem, that is where it comes from. You also, and then this is a finer, so this is 26 sectors. They also have a finer table with 100 sectors, so you can look at it more closely. The striking thing here, and this is personal consumption, 22 in 1990, 41, 56, 72, and then it jumps to 118, rising very, very rapidly, personal consumption. This is mobile phones, right? You have a little bit of vanadium in your mobile phone, and you can sort of like see it explode. So that is something you can find for particulates, for CO2, for methane, for a whole range of heavy metals. You can find this information if you are interested. They also have data on taxes, as I said. This is the total taxes paid to the revenue in 1997 and 2016. So you see environmental taxes more than double. You also see a profound shift in the composition, right? So green is households. This was more than half in 1997. It is less than half in 2016, right? So the environmental tax burden in this 20-year period has shifted heavily from households to companies, right? And you can read that in the environmental accounts. And of course you can do it for all years in between. And of course there's also finer detail on the types of companies. They also publish the material flow accounts, which essentially is how much stuff is floating around in the UK. Now what we're looking at here is biomass. Actually, crop residues are bigger than crops by weight, right? We have wood, not too much that here, fish cats. This is iron, this is other metals, iron I should say. And then we have minerals like limestone, clay, sand and gravel. And these are just, actually it doesn't have the unit. It has the unit of course if you go to the website, but I did not put it on here. This is probably in tons or maybe in 1,000 tons, right? And you sort of like see, well, this is all the stuff that is done in the UK. So this is domestic extraction. Then you can also look at how much stuff do we import. What you see if you focus on limestone is actually a good bit produced in the UK. And then there's only a tiny little bit imported, right? And that is because we have enough limestone in the UK, as you may have guessed, if you look around you in the landscape. Import a lot of food, right? That is what you see. Also import a substantial amount of wood into the UK. Substantial amount of iron. And the same for exports, right? Food exported, wood exported, not too much. Limestone is way too heavy to export, right? So all these things can be looked up in great detail for a great number of years. More and more countries are publishing material flow accounts, so you can now do this for the better part of the world, right? So you can sort of like look at how materials move over space. A former colleague of mine looked at cat litter, right? For those of you who have a cat in-house and you sort of like give it a little box, there's these little stones in there that absorb all this stuff, and you can actually trace where do these stones come from. And it's very simple. We dig up entire mountains in Africa, pulverize them, ship them here, and put them in a litter box, right, for the cat. And you can look at these things if you're interested. He was. You guys are less impressed. Besides the accounts that I just talked about, ONS also produces natural capital accounts, where they actually do not follow the peers classification of values, but actually look at the environmental services type of values, provisioning, regulating, and culture, and produce all sorts of data on this. So this is the provisioning services in the UK. In red, you're looking at fossil fuels, right? That used to be the dominant thing that we got from nature. But with the decline of production in the North Sea, that has actually fallen sharply. In blue, you're looking at agricultural biomass, so this is crops, right? That is much more important now. Water extraction in yellow. Renewables are sort of like still pretty small in there, right? Timber is very tiny because we import most of that stuff. So you can also see how these things change over time. This is another service that nature provides, that it cleans up environmental pollution. And if you're worried about PM10, then what this graph will tell you is that a lot of PM10 is absorbed by forest, right? If you're worried about ammonia, then a lot of ammonia is absorbed by grassland, right? So this is another service that nature provides. These things are bad for our health, and different type of ecosystems, managed, unmanaged ecosystems, absorb this stuff and make sure that it doesn't get into your lungs or other parts of your body and messes up your health, right? So this is an important service that is provided, and the ONS actually tracks this, right? This is where people spend their time if they're not working. Not surprised at all, because most people live in cities. Most people actually recreate in cities, right? Because it's around the corner. And that is the dark blue that you see, which is roughly half of the time spent. But then if you actually put a monetary value on this and you ask people, where would you like to be? Then the blue actually shrinks, and people enjoy very much being at the coast, right? That is the orange that pops up. Oh, going the wrong way. The orange in number of time spent is relatively small, but if you reweight this same data for how much people actually appreciate being in the coast rather than in some urban park, it actually blows up much, much more, right? So the ONS traces all these things and much, 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 much more, right? But I won't take you through everything they do, because I'd be talking for hours and it will not be very exciting. The World Bank also got into this stuff. The World Bank uses genuine savings, nowadays known as adjusted net savings. The main driving force is this guy here, Kirk Hamilton, and he is the chief whatever at the World Bank responsible for all this. And essentially genuine savings or adjusted net savings is the change in environmental domestic product, or rather looking at all the investment accounts that would be part of the environmental domestic product. So it's net investment in manufactured capital, that's investment minus depreciation, and net depreciation of natural capital, how much the environment gets better minus how much it gets worse, and also net investment in human capital is there as well. So essentially what genuine savings or adjusted net savings measures is our sum total investment in future consumption, right? It's essentially how all capital stocks change over time. Then of course, if your genuine savings is negative, then you're unsustainable. If it's positive, then you're weakly sustainable, because the assumption is still that an increase in manufactured capital could offset a decrease in natural capital, right? That doesn't matter for genuine savings. So this is the theory, right? Practice is a little bit different. So this is a standard measure, right? You can get this from NDP measures, but instead of having all natural stocks, they just have some fossil fuels, minerals, forests. They have CO2 emissions, but not other forms of emissions to air, let alone emissions to water or soil. They have PM10 in there, but not PM2.5, not nitrogen, and so on and so forth. And then for education, for the accumulation of human capital, they actually are completely in the dark what to do, and just look at how much is spent on education, right? Which is not the same as how much smarter do you guys get, right? Education spending is my salary, right? What the increase in human capital is you absorbing knowledge, and that is not necessarily the same. So this is how this works for Bolivia in the year 2003. I don't know why Bolivia. Gross savings, we start with that. Then we subtract depreciation of material capital, right? Man-made capital, human-made capital, I should say. So we get to net savings. Then we add the investment in education. We subtract depletion of natural resources. In Colombia or Bolivia, that is a bit of mining and a lot of forestry. And then we further subtract the damages done by pollution. And if these numbers are correct, then Bolivia is essentially, the consumption of the people in Bolivia actually comes at the expense of their capital stock, right? They're actually eating up their capital. They're not saving for their children. They're actually running the country into bankruptcy, if these numbers are correct. Can do this for basically all countries in the world, right? As I said, the World Bank has taken this up, and they're systematically collecting data for all their member countries. So basically all countries in the world that are inhabited by humans. The world is here. It's the squares. For the world as a whole, what you see is that we're roughly in total adding around 10% to the capital stock per year, right, over this 25-year period. So that is fine. East Asia is actually adding a lot more than that 10%, actually going up to 20%. A lot of this has to do with sort of like the build-up of the capital stock in China, and also the rapid expansion of education throughout East and South Asia and Southeast Asia, right? So that is why they're there. The OECD is actually, you can't see the OECD because it's almost always the same as the global average. Then what we have here is sub-Saharan Africa. It is a bit, they started negative, now they're basically hovering around 0. This is not good. The negative one is North Africa and the Middle East. This is essentially depletion of the oil stocks that they have, right? And essentially what you see is that they're eating up their capital but not creating enough human capital, creating enough physical capital to offset the decline in what essentially are stocks of oil and gas, right? So that is what genuine saving indicators will tell you. You can also do this for every country in the world. Sri Lanka is doing fine, Panama is doing fine, Austria is doing fine, Cameroon, Afghanistan are still doing a little bit fine, but if you look at Liberia, Timor-Leste, Mozambique, they're actually bang in the negative, right? And actually the one at the very, very, very bottom, Liberia, actually 84% of their consumption is by eating up their capital. That's a lot, right? That's too much. You can keep that up for a year and 2 months, right? But not much longer. Lots of stuff missing, right? I don't know why that fish is here. Natural capital, they exclude fisheries, they exclude soil erosion, they exclude water pollution, they exclude extraction of diamonds. Basically because data is very, very poor, not because they think it's not important. They're trying to set up an alternative system, the wealth accounting and valuation for ecosystem services, but that has not really gotten off the ground. What they're missing in human capital is the depreciation of human capital, partly because people are dying, partly because people are leaving the workforce, and partly because knowledge becomes obsolete because of technological progress. Certain skills that we used to have that used to be very valuable are no longer valuable, right? They also exclude social capital because it's so very hard to measure and define. And when you're looking at investments, they look at spending, right? So a bridge to nowhere is valued just as much as a bridge to somewhere, right? So it is entirely imperfect, but that is what it is. So this is what is going on in the world of sort of orthodox economics and what is going on around weak sustainability. There's also a bunch of people who are trying to measure strong sustainability. And I'll give you 3 examples of this, and people who are sort of like moving outside of the realm of orthodox economics. A very popular index is the Human Development Index. And it baffles me that people take this seriously, but lots of people do. So what is the Human Development Index? It contains 3 sub-indices. First, it looks at GDP per capita. Fair enough. Then it looks at life expectancy at birth. And then it has 2 indicators for human capital. One is the number or the fraction of adults that can read and write, and the second is how many kids are enrolled in school, again as a fraction of the number of kids that should be in school, right? And then this gets a weight of 2/3 and this gets a weight of 1/3. So far you think, well, this is okay, right? These are things that we care about, things that are easily measured. Life expectancy at birth is actually a very strange measure, because we don't measure your life expectancy at birth at all. What we do is a new child is born, and then we look at how many infants die, how many between 5 and 10-year-olds die, how many older people die, and so on and so forth, and you calculate those mortality rates per year group. And that is how we calculate life expectancy at birth of a newborn, right? Where essentially the assumption is that medical technology is static, right? And has been static for as long as the oldest person alive is the oldest person in the statistics, right? Which is, you actually would expect to live much longer than your life expectancy at birth, right? If you account for not just future technological progress, but also past technological progress. This is actually life expectancy at birth is not how long you expect to live, right? Absolutely not. It just sounds like that. It's a very strange measure. Then what they do is they measure these things for 200 countries or so. And then they scale that from 0 to 1, where the worst gets 0 and the best gets 1. And then they take the average of the 3 indices, and that's Human Development Index. And that is very strange, right? Because if you look at GDP per capita, that varies greatly, right? From the poorest country, which is probably South Sudan, but it may be Afghanistan, to the very richest country, which is typically either Bermuda or the Bahamas or Luxembourg. And then most countries are somewhere in between, but the relative ranking of a country or the relative distance between, say, the United Kingdom and France is determined by the relative distance of Afghanistan and the Bahamas, right? And if they grow further apart, then the UK and France get closer together, and if they get closer together, the UK and France get further apart. It doesn't make any sense, right? The relative distance between 2 fairly similar countries depends on irrelevant alternatives, right? Because of this scaling effect. And then, of course, the shorter scales, life expectancy at birth is actually fairly homogeneous over the planet, somewhere between 60 and 80 years. Small changes in that actually become amplified by this particular procedure. Right? It's absolutely not how you would construct an indicator that makes any sense, but that is what people have done. Right? The most popular one that I'll come back to is the ecological footprint. It really tries to measure strong sustainability. And then the one that is funniest is the Happy Planet Index. Sorry. Which measures life satisfaction, multiplies it with life expectancy at birth, and divides it by the ecological footprint. And this is an even stranger way of doing things than what is going on in the Human Development Index. So life satisfaction ranges between 2.7 and 8. This is essentially people or surveys asking how happy are you. Life expectancy is actually a bit wider than I just said, ranges between 44 and 75. So that is how these two count. And then you divide it by the ecological footprint, and the ecological footprint ranges between 100 and 0.02. And of course, once you start dividing by numbers that are smaller than 1, and once you start dividing by things that get very close to 0, the Happy Planet Index explodes, right? So this essentially, you're a bit early. This one actually dominates. And you can see that in the tables, right? So this is the Happy Planet Index. The ideal country in the world is Vanuatu, which is a reasonable thing to say because nobody knows what life is like at Vanuatu, right? Almost nobody, because nobody lives there. Colombia comes number 2. That's a bit peculiar, right? Things are not ideal in Colombia. Cuba comes number 6, right? Cuba, the 6th happiest country in the world? Nah. El Salvador comes number 9, right? And there's a lot of people being moved to El Salvador against their will, right? Zimbabwe comes bottom, yes, that I believe. Congo comes bottom, yes, I believe that. Estonia, close to the bottom. Estonia is a good place to live, right? Now let's look at countries that you know better. UK comes number 108, just below Libya, right? Who here would like to move to Libya from the United Kingdom? This index predicts that you will be happier to move into a situation of civil war, right? The United States is almost on par with Côte d'Ivoire, right? It's one of the most wretched countries on the planet. And the reason is this ecological footprint, right? That dominates the calculations, right? That dominates the calculation. So what is the ecological footprint? It's popular. It's very popular. It's due to these two guys, Bill Rees and Matthijs Wackernagel. And essentially what they try to do is come up with a measure of strong sustainability. And what they say is the ecological footprint is the appropriated carrying capacity. It consists of two things. One is how much land do we use, plus how much land do we need to take away all the bad things that we do. Right? And that is then divided by the amount of land that we have, right? So this is an absolute yardstick of value, just as I talked about in, I believe, lecture 4. And the absolute yardstick is the amount of land that we have, right? So in a way, this is physiocracy, right? In terms of where are we in economic history, we are before Adam Smith, right? In terms of intellectual development. We're back in the earlier parts of the 18th century. So, how do they calculate this appropriated carrying capacity? Grazing land footprint, simple, right? How much land do we use for grazing? Forest footprint, simple. How much land do we use for forests? Fishing grounds footprint, what if we replace all fish protein with animal protein? How much land would we need for that? That's a bit weird, right? That's a bit very weird because we do use the ocean. We can use the ocean, right? We have an ocean there. These things are simple croplands and build-up lands. And then, how much land would we need to absorb all the CO2 that we emit? We emit lots of CO2 by burning lots of fossil fuels, and you can absorb that CO2 by planting trees. How much land would we need to plant all those trees to reabsorb the CO2 that we emitted? Of course, there's other ways of avoiding CO2 emissions, but this is what they do, right? And then this is the implication over time, 1961 to 2007 for the world as a whole. Build-up land, right? So this is houses and stuff. Tiny, tiny fraction of the Earth's surface. Croplands much bigger. Forests much bigger. This is the forest that we use, not the forest that there are. Grazing, fairly substantial. But what you see, and that is the thing that comes on top here, about half in 2007 of the ecological footprint is by the CO2 that we emit, right? And the amount of land that we would need to absorb that again. So this is the total amount of land that we need, right? This is the total amount of land that we have. And what you see is that we're absorbing more than the planet that we have, right? So this is a cause for alarm, according to these people. They do this for the world as a whole. They also do this for every individual country. And then they put this on the calendar. And what you see here is that by February 11, Qatar has used more land than it has. February 16, Luxembourg follows. Whereas the UK, May 16, it's next month, right? 4 days after the exam, actually. The UK will use more land than it has, right? And you can continue. This was, of course, 5 years ago. They also have done this for 2024, but I think I'll put it on the slide. So this is the ecological footprint. As I said, the way they account for CO2, which is actually the dominant thing, is just bizarre. Because CO2 is not about land, right? It's about stuff that is going on in the atmosphere. There's other things is there, right? There's many more environmental problems than climate change. Water isn't there at all. The weirdest thing is that, yeah, this sort of makes sense for the world as a whole, but to do it for a country, right? I mean, the reason that Luxembourg pops up so very early is because it's a tiny country that is very densely populated, and most of the stuff that is consumed in Luxembourg comes from outside of Luxembourg, and mostly what they do is export services, right? That is financial services mostly. That is, and a little bit of publishing. That is what Luxembourg does. And the reason that Qatar pops up so very high is because it's a tiny country and that exports a lot of oil and consumes lots of other stuff. So yes, countries that trade a lot, and definitely countries that are sort of more advanced and do a lot in services and import a lot, they will be hammered by this index, right? And essentially by saying, well, you can only consume that sort of stuff that your sovereign jurisdiction can bear, you're essentially like Donald Trump. Some people over the weekend have called Donald Trump woke because he is essentially in favor of autarky, right? Just like these extreme left academics are, right? Essentially this measure by saying, well, you can only consume what is in your area, you're essentially saying international trade is verboten, right? It is a measure of strong sustainability in the sense that we're looking at what happens to the natural capital stock. But at the same time, it allows for substitutions within these natural capital stocks, right? They're not trying to preserve every individual species, every individual component of natural capital. They're just looking at natural capital as a whole. So that's it for today. If I had time, I would speak about how not countries do this, but how corporations do this. But I don't have time for that. So I hope to see you guys tomorrow or Wednesday.